This is the second video I'm creating on the use of Flir tools in order to perform image analysis and thermal tuning on the infrared thermographic images that you've collected as part of your NDT projects. In the first video, we activated Flir tools and then loaded a file that contained images into the software, and this is where I left off. And you can see that folder that we brought in right here, Flir tools walkthrough. And clicking on that, it contains two images, one that I'm going to use to show you reflected temperature in this video, and then one that I'll show you an emissivity measurement example for in the next video. To find reflected temperature, I'm going to open this, and I took these. We have the option over here, parameters on the right side. You'll notice if you have had an opportunity to use the cameras, these are the same parameters that can be adjusted in the camera while you're taking images. However, if for some reason you haven't set them, or a lot of people it's just easier to come in and do this after the fact using the software rather than trying to do it on the camera. So a lot of people just leave these standardized. An emissivity of 1 that's shown here on the right basically negates out pretty much everything else. The reflected temperature, distance, atmospheric temp, external optics temp, external transit, all of this stuff basically doesn't do anything as long as this emissivity is set to 1. The other thing, the external optics temp used for a window, if you're using an infrared window with that set to 1, transmission of 1 means 100% transmission. That means you're not looking through a window, and so we leave that at 1. That takes the external optics temperature out of the equation as well. So right now this is the raw image. It's just showing the information. Each pixel on the camera is a temperature, and so you can see in this case it has an infrared resolution on the right side of the camera information. This was taken with our E95 camera. It even has stuff like the serial number. It has the lens that was used, and then it has the resolution. So this is, a lot of people are used to hearing 1080 and that kind of thing, high definition. Well, this is not nearly high definition, but it's 464 by 348, so it has a resolution of 161,472 pixels. So there are, in this entire image, 161,472 temperatures that the camera took simultaneously. And then things like date and date created in that. I can tell you right now the date created here is not accurate. I don't think I had the date set in the camera when I did this one. But in order to do reflected temperature, what we're going to look at, we have an image of our diffuse reflector, the crinkled aluminum foil, that's going to tell us how much infrared energy is being kind of bouncing around the environment where these images were taken. And so to do that, we're going to take kind of an average temperature. This is reflecting from all different angles. So if we go over here, we can add a box measurement tool, and we want to create a box that covers most of the reflector. However, we don't want it to extend off. So like this bottom left corner, I'm a little too far over, so I'll just bring this over. It's okay if it doesn't quite cover the whole image. The big key is we don't want it to go anywhere. And you can see this created this box on the right side. It says box 1. Gives me a max temp, a min temp, and an average. The only thing I'm really worried about right now is this average temp. And actually what I can do is I can right click on here and I can do a few things. So local, min, max, average markers, I can turn off that maximum and minimum. To me it doesn't really make a difference. I don't need those, I need just the average. This bottom one here, area, actually allows me to do a measurement area. If I do that, it'll tell me how many square inches. The problem here is you can see distance is set to 0, and so it can't calculate that. Okay, but we're not using that for our purposes yet. We'll use it for measuring a flaw later. So here's our box. We want our emissivity. We're going to leave that at 1. If the emissivity is at 1, it doesn't matter. We're measuring reflected temperature. Reflected temperature will not do anything unless we change the emissivity first, if it's not 1. So everything else we don't really need to worry about. As long as emissivity is 1, external optics are 1, this is going to give us our average reflected temperature, so 78.1 degrees Fahrenheit. We're going to take that number and we're going to use it in the next video to find the emissivity of a test box. So I'm going to write that down, and then we will enter it in when we're analyzing it. Before I go, if I want to keep this or want to be able to include it into a report where I can show my box, I can save the image, and then or save and close. If I hit cancel now, I've saved it already. You can see I'm back to this screen. If I double click on that reflected temp example again, you can see now it's still got the box in there and everything I put in place. So at this point, I'm going to say the next video we're going to look at the emissivity example, and then after that we'll do a measurement example as well.